When you start out with a big data strategy, it has to be around how you can help the citizens better, how you can be a better steward of the taxpayers' money. So I would combine a business thinking approach and a design thinking approach, creating a persona in the end user of a citizen or an internal person working for my organization, and what type of insights do they need to glean. And then, of course, that needs to be prioritized with the other use cases that you have and the other personas that you develop and understand around big data use cases. And the way you should prioritize them is the public value that you can get from creating an initiative like that. Can I utilize my current data and the structure it is in place, and can I create more value and glean new insights that will help my citizens or help my particular mission? The other thing that I think is important is you need to have what I would call a realistic view of that particular big data initiative. It has to be politically and also feasible. Politically feasible and also from a business perspective feasible. So you could think of lots of great things to do with big data and different insights that you think you might be able to find correlations that you never thought of before. But if it's not feasible within a budget and it's also not feasible politically, then it's not useful. And this goes back to the big data use cases. If you can understand that you need to create a particular solution for a specific area for big data. So big data has use cases all across a spectrum of topics. Solving traffic flow issues, solving crime, combating crime better, homeland security needs, finding better insights into finding terrorists or others that will do harm to us, the patterns of weather and how they will affect society. The use cases go on and on, but the understanding of big data has to be around the public value that it could bring. And you also have to understand what your current infrastructure is from your technology. How is that big data coming into play? And the difference between big data and what I would call regular data in the past is it's not only the variety is changed in the recent past with lots of more unstructured information from social media and video and different other types of unstructured information. Combine that with the transactional information, but also you have the volume has grown. And given that volume, your current infrastructure might not be able to deal with that. So you have to understand what the new volume of information might be to your organization and how you can glean insights from that, finding the pin in the haystack of pins that you need. There's a lot of best business practices. One is understand how good your data is today, understand where those sources of data need to come from. Is data available that's open? So sometimes we don't talk about that, but there's lots of open application program interfaces today that lots of different government agencies are opening up to other citizens or to the citizens in general, but other agencies can now access different data sources to glean more insight from those as well. Yeah, that's a great question because there is no one size fits all. People think of unstructured data warehouses or in-memory computing. It really goes back to the use case. In one particular use case that I think is interesting, one commercial organization is actually taking human genome analysis for cancer patients. They're utilizing a Hadoop data store for unstructured large volumes of data. They're utilizing an SAP HANA database for real-time data insights. And they're combining that information to understand where that particular patient needs to be from where they are today, their genome makeup today, where they need to go from where their genome makeup needs to go to be normal. And in the past, 5 years ago, this didn't exist, the ability for an individual patient to understand and a doctor to understand that particular diagnosis. But then as time has gone on and big data technology has advanced, we can now do that information before the patient leaves the hospital, diagnose and understand where their genome needs to be in a normal state and get a prognosis and a prescription as to how that patient needs to be treated before they leave the hospital, as whereas in the past, you not only did not have that information, but if you had that visibility, it was weeks later because it took so long. So you're combining lots of real-time information and historical information in one view.